So we had this at the end of the I think the second or the third lecture in the course. So this is the Tf-Idf Weighted Sum, and we said that out of the box, this is your state-of-the-art ranking formula that you would use for ranking documents in response to short queries. So it is state-of-the-art. Google's using it, Bing's using it, or variants of it. And the question that you want to think about this, now that it is comfortable and friendly and familiar and you know everything in this formula, is how did this thing really come up, right? How did somebody come up with this formula? Right? In the vector space lecture, yes, we had an explanation for what parts of it do. Right? So we talked about these observations. The sum represents that that the overlap between the query and the document is very important, and TF represents the fact that repetition of words tends to be important, and IDF represents the fact that rare words are more important than frequent words. So yes, we can explain all of the components, but it's one thing to stare at the final result and be able to explain it. It's another thing to be able to come up with that. Right? So the question is, how do you come up with that? Why does it have exactly that form? Why do we have a sum and not a product? Why is this log and not the square root or not a squashing function of some kind? Why does that look like that? There are hundreds of different formulae which could be explained using these observations. But this is the one that works. So how did this come up? And really, the reason you're asking the question, how did this come up, is the question that you're much more interested in answering is, how do you make it better? And to make it better, you need to understand how you come up with something like that, so that you know which parts of it to take and to try to replace with something else. So, and the unfortunate answer is it didn't really come out of the vector space model, right? So the way that I presented it, that's not how that formula appeared. It came from a completely different model. The vector space model, it's really nice. It's really flexible. It allows you to use any weighting scheme and any combination formula that somebody tells you might be good, but by itself, it doesn't give you any suggestions of what you might want to try next. It's too general. It's too general for its own good. It doesn't restrict your movement in any way. So if I asked you, you're working on a vector space model, what do you want to try next? You have a million opportunities. If you have a slightly more constrained model, and we're going to talk about a probabilistic model. When you work in a probabilistic model, you can't just try anything, because you can only try things that make sense probabilistically. When you're working with a probabilistic model, you have a set of rules or semantics, and you have to follow those semantics, and your set of choices at any point is really, really restricted. Right? You can there's a couple of rules that you can use in probability, or you can make assumptions, and those assumptions have very specific form, and they lead to very specific transformations of the formula. So, so that's what we're going to do today. We're going to look at the probabilistic model of retrieval, and what it is, it's a mathematical formalism for defining, for describing relevant and non-relevant sets of documents. So what we're going to do is we're going to introduce some random variables for the documents, the queries, and for relevance between them. We're going to be very specific about what the possible values for those variables are, and we're going to try to prove a couple of simple things and then derive a ranking formula by making a sequence of assumptions. Right? So you will actually understand what you're assuming when you're making certain transformations to the formula.